Well, good morning and good afternoon, ladies and gentlemen. Welcome to another BICSI South Pacific webinar. We're delighted to have a speaker from New Zealand, Phil Earl from Talk IP. We're going to be talking about passive optical LANs this morning. So it's a product that, product set that's been around for a long time, or technology, should I say. Lots of discussion about it, and I have to say in my conversations with Phil, delighted to see that the uptake is quite significant in New Zealand. So we're looking forward to learning a little bit about this as to how the technology has been successfully deployed. Just a little bit of housekeeping as a starting point. So if we could just advance the slide to the next slide. Just some housekeeping. With regard to questions, we typically have a number of questions that pop up through our webinars. If you could just hold off until or pop them up on the chat box. Our moderator, who is Craig Buckingham today from R&M, who's very kindly provided the GoToWebinar platform for us to run our webinar this morning. If you could just pop them in the chat box. Craig will then aggregate those and we'll discuss them later on. There will be Q&A time available later at the end of the seminar. And of course, the important aspect of those of you who are BICSI credential holders, we will be lodging this program with BICSI US to obtain a CC point for it. So it's all part of the program that we have. If we go into the next slide, just a little bit of detail as to what's on for the program. It's just slightly over an hour. Just a quick introduction from myself, and then we'll hand over to Phil Earl as he talk about passive optical LANs, and then we've got a Q&A session thereafter. Just on to the next slide, thanks. Okay, just a quick update. We've had lots of questions about what's happening with our events. Courtesy of coronavirus, needless to say, all of our events have been closed off through the year. I am happy to say with coronavirus abating in various parts of the South Pacific, we're aiming to run seminars in New Zealand, Auckland, Wellington, Christchurch, 24, 25, 26 of this month. We're currently in the planning phases for that. Perth will be holding a seminar in early December. And interestingly enough, they're holding a golf day at the end of this month. Sorry, the end of this week. They are literally oversubscribed, which is delightful to hear that people are keen to just get back to normal as quickly as possible. Sadly, we're turning people away from the golf day because we just don't have the capacity for them. So that's a good indication that people are keen to get back to norm. Moving forward into 2021, assuming coronavirus will have abated in the rest of the South Pacific, early 2021, we've scheduled our New Zealand conference for the 11th of May, which will be held in Auckland. Our Australian conference is planned for October, November. We haven't got dates booked as yet, but we're aiming to do that. And of course, we're looking in holding it in Sydney. And we're looking to reintroduce our seminars, subject to restrictions lifting, in various locations. So perhaps places like Melbourne, it might be a little bit later where I am, but other places earlier, perhaps South Australia, Queensland, etc. We'll start seeing those coming in a little earlier, which will be a delightful thing. And of course, due to the success of our webinars, we've basically got a program that we've got a lot of interest in the ability to provide education sessions such as this one on a regular basis. So the plan is to continue these, and we'll just work through the program early next year. That's it for me. If we, I'll just hand over now to our speaker, reintroduce our speaker. Phil Earl is a technical director for Talk IP, which is an end user advocate, working closely with a number of end user organizations in New Zealand. Personally, I've known Phil for many years, very strong technically, and has quite an appetite for the latest technologies. So Phil has researched passive optical LAN quite extensively over the years. And in the course of our conversation, I've learned that he has quite the vision for how it commercially works and works well in various markets. So let's hand it over to Phil, and please enjoy the program. Hold your questions and we'll discuss towards the end.
Thanks very much for that, Paul. Just quickly outline the agenda for today. We're providing you with a passive optical LAN overview, and the agenda we'll go through is the total cost of ownership, NZ market verticals, and where we've seen good take-up of passive optical LAN in New Zealand in particular. We'll have a quick look at the traditional cabling versus the passive optical LAN. Environmental impacts, which was one of the really big strengths that passive optical LAN brings to building projects. Passive Optical LAN design tips. I thought I would just share a few of the initial hiccups that we see with Passive Optical LAN designs, and then Passive Optical LAN installation tips as well. This particular presentation that I'm doing is just a small portion of an online training course that I delivered last month. So when I had the opportunity to present for BICSI, I said to Paul, no problem at all, I'll do it on Passive Optical LAN. And I thought I would just take a selection of slides from that, that training course to share with you. So we have a look at savings. So obviously one of the big things with Passive Optical LAN is the total cost of ownership. And I'm going to just quickly play you a quick video, and we're in no way associated with this video, but it does provide you with a really good guide on the savings that are possible with Passive Optical LAN.
Information technology is the backbone of commerce, government, and national security. Legacy local area network architectures have remained largely unchanged for decades, while costs have continued to increase. IT requirements demand 3 modes of communication: voice, video, and data. Each mode traditionally uses an independent infrastructure. 3 separate infrastructures means needless consumption of precious natural resources, which translates to increased capital and environmental costs. Using proven fiber to the desktop technology, Leidos is delivering a next-generation solution that converges these 3 communication infrastructures on a single fiber. This Ethernet solution is known as a Passive Optical LAN, or POL. A POL delivers gigabit fiber optic connectivity with a greatly reduced cabling footprint and simplified architecture. This reduced complexity translates to savings of up to 60% on IT operations and maintenance costs. At the core of POL, Optical Line Terminal, or OLT, reduces floor space consumption by 50% as it converges the voice, data, and video signals onto a single fiber. That single fiber runs through a reduced cable pathway to small fiber enclosures mounted in ceilings, under raised floors, or in electrical rooms. These fiber enclosures no longer require equipment riser closets. The removal of riser closets also allows for the elimination of electrical power, air conditioning, and costly Ethernet switches, resulting in more than 40% savings in IT-related energy costs. In the fiber enclosure, fiber splitters replicate the single fiber to multiple fibers, which extend the optical network terminals, or ONTs. The ONT converts the optical signals to traditional Ethernet interfaces at the desktop, which allows for a 50% savings in IT installation costs. The benefits of POL extend beyond a single building. Using advanced fiber optic distribution technology, a POL allows secure signal transmission to more than 20 miles with no power devices between the data center and desktops. The POL architecture centralizes expensive IT equipment and support personnel in one main location. POL enables government, commercial, and national security organizations to revolutionize their IT infrastructure and deliver superior performance, lower total cost of ownership, enhanced security, and more effective use of natural resources.
So that provides you with an overview of Passive Optical LAN and where the total cost of ownership is. And often with sales presentations, we get a lot of end users asking, does it really translate to those level of savings in the real world? And the answer that I can say in short is absolutely yes. That's the thing that we found with the number of deployments that we have undertaken. And if we have a look at the NZ vertical markets that we have currently here, there's obviously a number of aged care facilities and villages that are utilising Passive Optical LAN. We're in the middle of a project currently advising our customer with the deployment of Passive Optical LAN in that particular arena. We also have it in hospitality, which is quite a large sector. So there are a lot of hotels that are utilising Passive Optical LAN in NZ. We also have education sector here in NZ. So currently it is the primary and secondary schools that are utilising it, but there are some of the universities and tertiary institutions that are considering deployment of Passive Optical LAN. And of course, education internationally, there are a number of large passive optical LAN deployments in other countries. Government departments have certainly embraced this particular technology, and it's my understanding in the US is that they actually mandate passive optical LAN deployments, particularly for its security aspects. And here in NZ, there have already been a number of government and local government installations deployed, and we've been involved in a number of those ourselves as well. Looking at the education sector in particular, currently we have 15 sites that we have deployed passive optical LAN in. Of course, the education sector, particularly primary and secondary schools, they're renowned for having tight budgets. Architects are always wanting to save space because, of course, the school environment, they want to maximize the learning space, not the space given to, riser closets or man equipment rooms, etc. They also want to be future-proof because we have school buildings that have been around since I think Captain Cook discovered the country, but there's certainly a number of aged buildings, so we need to make sure that the infrastructure that we're putting in is definitely future-proof. And we have bring your own device or bring your own technology demands here in NZ with a national rollout of wireless infrastructure currently underway in a refresh program. So there are a number of demands on school networks. Now we have over 10,000 plus students across these 15 different sites. There's over 15,000 optical network terminators. They're looking at deploying voice over IP, Wi-Fi 6 WAPs with 802.11ax is the alternative IEEE standard for that. We have a lot of CCTV cameras deployed on the system, media streaming, and obviously much more. So the sites range all over the country, from Wanaka South in the South Island, Rangiora West, Redcliffs, Waimari, Linwood College, Mount Aspiring College. Talking of Mount Aspiring College, that is the image that you actually have on the screen in front of you, and you can see my cursor here. So the main body of the college is this area here, but Mount Aspiring College is one of the unique colleges here in NZ, and it's down in the Wanaka region, which is just adjacent to Queenstown for those that are familiar with Queenstown, New Zealand. But over here, you'll see there's another village. This particular village here also belongs to the school. They actually have a hostel there for a program that they run regarding outdoor education and alpine pursuits. So that's where they train different students that are wanting to specialize in those particular areas, and that's their accommodation. So they may be golfing stars, skiing, snowboarding. There's an awful lot of stuff which happens down in Queenstown. And you can see from a distance perspective, the main college campus is over here through to the hostels that they have for, or houses they are actually for housing the residents, I should say the students that are staying here. And passive optical LAN, with the size of this particular campus, is the perfect fit for that type of installation. We also have other colleges like Otamotai College, the Hagley Community College in Christchurch, Mana College, a new one in Christchurch, Wainui in Wellington as well. Sorry, Mana College is in Wellington. We have Ngaruahi High School, which is a new one which we've just finished designing, and that's down in the Waikato region. We have one that we've called ABC School, and that is a new campus that's been put together post the earthquakes in Christchurch, and it's a combination of Allendale Special School, Burnside Primary School, and Cobham Intermediate. So again, a large campus bringing 3 schools together onto a single campus, and passive optical LAN is a very good fit for those sorts of situations. If we have a look at some additional benefits here, this particular example we have is Rangiora West, and as you can see here, there's the actual main equipment room. Now, one of the unique things about this main equipment room is the architect actually reduced the size of the room without consulting the designer. So it went down to 2 meters by 2 meters, hence the back of the cabinet is actually against the wall, and you can see there's not a lot of space behind it. But the school has still managed to provide some space for storing boxes of IT equipment in there, and there's still a relatively large amount of space in the base of the cabinet as well. So the free space where additional cabinets and cabling would have been obviously is now utilised for storage. Air conditioning within the room hardly runs, as you can see it over here on the right-hand side. Cable tray not used either, as it was not required. The cables are instead installed on catenary wires, because obviously much smaller than large bundles of copper wires. And the installation time frame obviously much quicker than traditional cabling for this or a traditional LAN solution with utilizing passive optical LAN, where you can see the ONT mounted here in the ceiling space with patch cords running away to wireless access points or CCTV cameras, and then the fiber optic patch cord, which is this white lead here, which is an armored patch lead running up to the ONT. Looking at other industries, here's a few installations to mention. Environment Canterbury was one of the first ones back in 2012. Genesis Energy, Ministry for Primary Industries. We've got the Wellington Airport using Passive Optical LAN. Bay of Plenty Regional Council, which we've personally been involved in. You have the UCG head office, which does the planning for the ultra-fast broadband fibre. You've got Network for Learning, which manages school networks in New Zealand. We've got the Far North District Council, Porirua City Council, Landcare, Waikato Regional Council, which we're involved in as well, Greater Wellington Council, and over 15 hotels, and there's many, many more. But if we have a look at the trade-off between outlets from a copper perspective and ONT, so each ONT typically has 4 outlets. That's because the form factor of the 4-outlet ONT is the most prolific. The broadband rollout, also ultra-fast fibre rollout within NZ is probably close to 90–95% complete. And at the end of each of those fibres that goes into each of the residents that take up fibre, like I have at home, then they typically have a 4-port ONT on the end of them. And hence, from a cost perspective, it's the most prolifically used in its economies of scale again, so therefore they're the most cost effective. So if we take 2,800 outlets, that equates to over 700 ONTs, which, and if we have a look at Waikato Regional Council, they also deployed, rather than just using 4-port ONTs, we had a specific situation where the meeting rooms that they had and the AV connectivity required for the room booking system, the wireless access point, the streaming media input, the room control, exceeded those 12 ports. So to future-proof the installation, we selected a 12-port ONT and deployed that in the meeting rooms. The advantage of that particular 12-port ONT from that manufacturer, it has an SFP interface, which easily allowed us to actually migrate from 2.5 gigabit PON to 10 gig HDS PON in future by changing out the SFP module within the actual ONT. So a simple migration later, and we also selected to engineer it so that the wireless access points typically sat within the meeting room to provide the most reliable and so not just reliable, but from a performance perspective, when you're in a meeting and you always want to stream and connect, you want to make sure you've got good, solid, reliable wireless. So we mounted and mapped the wireless around the meeting rooms. It also meant that if they did then change to the 10 gig Passive Optical LAN in future, the wireless access points could actually take advantage of that as well. So we looked at Ministry Primary Industries. This was a classic situation of them looking at traditional cabling, and as you can see there, massive ladder racks full of Cat6 UTP cabling versus what they ended up with, which is the yellow cabling. As you can see here, each one of those yellow cables carries 12 fibers out to a rapid deployment terminal, and each one of those 12 fibers obviously can connect to a 4-port ONT. So it's incredible the amount of space saving, and as you can see, that that wire basket that's installed is very underutilized, and that's part of the reason why within the school environment we didn't go with wire baskets. We just installed catenary wires. You'll also notice that from a segregation perspective, the fiber optic cabling, which is running past the power cabling, segregation isn't there, and of course it's not required because there is no interference from the electrics on the Passive Optical LAN. Looking at Environment Canterbury, now this was a classic case of unfortunately a little bit too late to inform the architect about the space savings, and also the IT department were clever in the fact that they knew that they didn't have a huge amount of storage, so they held back, and as you can see, there's a lot of IT equipment actually stored within this particular room. So when they made the decision to switch, they didn't actually downsize the room. So this was installed in 2012, Nokia and CommScope installation. The space the architect allowed for the traditional MER layout and cabling has, as you can see, still exists. The space where the cabinets and cabling would have been is now obviously used for storage. Air conditioning is over-engineered. As you can see, there are two air conditioning units here, and they hardly ever run because the amount of heat that's actually generated out of this one cabinet that's on the left-hand side here with the OLT and the twin-core switches, you've only got one local server. The rest of their equipment is actually based in a data center outside of the building from a resilience perspective. And the surprising part about this particular installation is it took one installer. So this is 2,000 outlets, I think. Well, actually, if we quickly go back, no, 1,200 outlets, sorry. 1,200 outlets installed within this particular installation. And those 1,200 outlets took one installer 6 weeks. There was an exception to that. One day only during those 6 weeks, there were 2 installers on site. And the reason for the 2 installers was to install the cabinet, because obviously one person can't lift and maneuver a cabinet of that size into place. And there's a fiber distribution hub, a 12 rack unit wall mounted that's just sitting off the screen here. That was the only day that 2 installers were required on site to actually do this installation. So if we have a look at meeting room design, this was a Environment Canterbury design which they came up themselves with this particular credenza, and obviously they cost a fair amount to build. They were $5,000 each. The fiber faceplate, as you can see down behind the actual cabinet here, mounted on the wall, and then they have an armored 3.5mm single mode patch lead from the fiber faceplate, or FFP as we call them, onto the ONT, which was mounted in the center of the credenza. And that then feeds the VC unit on the top, and obviously the speaker, etc., links through to the credenza as well. The benefits that are achieved with ECAN, obviously, they were able to put a number of ONTs around the place, down in the car parking for CCTV and camera and environmental monitoring, up in the plant rooms, under the desks, and obviously the fiber base plates coming out and just connecting to each of the ONTs. In the aged care facility, a quick example of what's possible in aged care. Obviously, the personal emergency response systems, also known as nurse call systems, are connected to it. Intercoms, the voice over IP platform, through to PCs or search stations for end clients, MATV running or SMA TV running over the system. We have obviously wireless access points, much tighter comms closets. We have CCTV cameras, smart meters, electrical smart meters, and obviously security and gate controls also running on the system as well. So having a quick look at what it looks like in a particular village, you can see there with the primary home distributor mounted in, say, each of the villas or each of the apartments, and a layout of that. You can make it extremely tidy with an ONT installed in each of those locations. Quick diagram again, looking at how it used to look before within the aged care facility. We came along, we did some remediation work, and what it would look like afterwards. So a big difference between the traditional cabling methodology and the passive optical LAN methodology. Looking at multi-dwelling units and traditional cabling versus passive optical LAN. In the traditional LAN, obviously we have the riser, and within the riser we'll have our backbone cabling, our horizontal cabling out to our endpoints, telecommunications outlets, or if we're talking with ASNZS 1101.1, the generic cabling systems now. This is an office, obviously, so we still use the term telecommunications outlet within .2 of the new standard. That's ASNZS 11801.2. So we have the traditional LAN here with our building distributor up to our floor distributors. And again, if we're using terminology from 11801.1, we're talking about subsystem cabling 1, subsystem cabling 2. If we compare that and all of the cables that are required in a traditional building, so obviously we typically run fiber in the backbone, up against passive optical LAN, here we are having to put cabinets in the traditional, cabinets on each of the floors, a building distributor, floor distributors. On the passive optical LAN, because we have that 20-kilometer reach, we can put the OLT or the head-end electronics down in the building distributor in a central location. We then have passive optical splitters, so it's all passive from that point out on each of the floors, if that's how we choose to do it, or we can still centralize all of those passive optical splitters back here, as you saw with the InCAN installation. So we have a lot more range and flexibility of how we engineer the solution, but essentially the endpoints from the ONTs come all the way back to the OLT. So there was a reason that Environment Canterbury also chose passive optical LAN. There is a number of credits that you can get. Here in New Zealand, we use Green Star rating. I'm not sure what the environmental rating is for Australia. I think it's LEEDs in the US. And there are two main categories that passive optical LAN can help with a building Green Star rating. These are energy and innovation credits. So within the different sectors that you can see here with management, indoor environment, quality, energy, transport, water, materials, land use and ecology, emissions and innovation. So if we have a look at the scoring that you can get from the two different sectors, there are 31 points available in energy. We can have a reduction in telecommunications rooms, HVAC equipment, switch equipment, UPS, lighting, and other energy requirements. The passive optical LAN system also helps, of course, the overall efficiency of energy systems. So there are the different scoring areas within that particular points category. And then under innovation, of course, the passive optical LAN system uses less equipment, resulting in less raw materials being used, less waste, lower transportation, and reduced deployment time and commissioning. ECAN, as I said before, 1,200 outlets, one installer, 6 weeks. Additionally, using fiber ensures the system life extends beyond a conventional switching network system. So there are the 10 points from an innovation perspective. So how much does the power cost? So everyone keeps saying that, you know, passive optical LAN, excuse me, is more efficient. And from an efficiency perspective, what sort of financial benefits and gains can we actually get back? Are there any tangible case studies or studies that have been done which tell us exactly what the savings can be? So I thought I would take an American study which has been done on a medical facility with 4,000 outlets and translate it into utilizing our local power to see if it's still costs, to see if it's still stacked up. So if we look at Auckland as being one of the ones with the cheapest power at 27 cents per kilowatt hour, you can see if we were up in Kerry doing this passive optical LAN installation, it would be 41 cents. But what I've done is I've zeroed in on the 27 cents to actually do the calculations. So on the left-hand side here, you'll see a traditional network, which is 4,000 drop points or 4,000 outlets with Cisco switches on the left-hand side here versus a OLT and a passive optical LAN equivalent on the right-hand side here. One of the areas I would like to zoom in on, though, or hone in on, that is often not calculated properly within the actual calcs, is the actual heat loss in PoE. So if we're looking at traditional cabling here, you're talking about, say, an average run of 60, almost 61 meters there, and the actual amount of wattage per month lost in heat due to the losses in the UTP cabling is 760.76 watts versus the patch cords from the ONT to the end device from a PoE perspective of being 30.43 watts. But overall, if we actually look at the two, in the summary up here, you can see the 27 cents that I mentioned before. That's NZ Power prices. And looking at the total budget from a passive optical LAN perspective, the total savings are 62.21%. Or if we talk about dollars and equate this particular installation to dollars, that's a saving of almost $55,000 a year through the deployment of passive optical LAN. So you can see that there is quite a large amount of savings. So when end users or clients think about power savings, they often want to quantify it, but most miss the smaller but crucial savings with passive optical LAN. And that is the power loss in the cables when using traditional power solution due to the increase in the average drop length. For this particular example I've been talking about, of course, the traditional installation losses equates to, as you can see down here, I mentioned before, 760.76 watts per hour, or 18,258.24 watts per day, or as this facility is 24/7 by 365, a total of 6,664,257 watts per year, or an additional 6,664 kilowatts of energy per year. So moving on to, again, environmental savings, and we're talking about raw materials. So when we look at each one of the 3mm diameter armored zone cabling backbones for passive optical LAN, which is just here on the left of the image, each of those carries obviously 12 fibers, and we compare that to the bundle of orange category 6 cables here and the grey ones on the right hand side here, which is 144 Cat 6 copper cables. And if we allow each of those 12 fibers to connect to a 4-port ONT, this would result in only 3 of these cables on the left-hand side here being needed to provide the equivalent 144 outlets of this particular bundle. But this bundle over here of the passive optical LAN actually has 12 core fibers in it, and that equates to the equivalent of 576 service outlets. So while you've got 144 here in copper, on the left here we have 576 outlets off of ONTs. So reduced power requirements saving between 40 to 60%, reduced HVAC requirements. In the US, a Fortune 500 company saved $450,000 on power distribution network, HVAC backup, etc. for a building project with 2,000 Ethernet ports. You have reduction in non-renewable material, so a reduction of up to 3,600 kgs, and this is in the medical example that we were just looking at before, or 3.6 tons of plastic and copper versus a category 6 installation for that building of 4,000 Ethernet ports. So if we were to substitute that installation, as you saw before, with passive optical LAN, these are the kind of savings that we would have made. Floor space savings, traditional layer 2 solutions are constrained by obviously the 100-meter Ethernet limitation. And you also have fire load savings, savings on sprinkler systems, fire load in ceiling spaces, the number of core drills that you have to have because of the size of the holes, the amount of material that you're actually having to seal within those core drills as well. So if we have a look at some additional environmental savings and comparing the size of the different cables, you can see there, if we have a look at 10 gigabit Ethernet and its capability, 40K on single mode fiber, 45 meters on 5E, 100 meters on Cat 6A UTP. But the real differences come in the weight. So if we have a look in the diameter, so the 12 core rapid deployment fiber terminal is 3 millimeters in diameter. For a Cat 5E, you're talking 5.7 millimeters, 7.5 mil for a Cat 6A. That equates to, in weight, the fiber is only 1.8 kg per 305 meters, 10 kgs for a Cat 5E, and obviously 17.7 kilograms per 305 meter for a Cat 6A UTP solution. Bend radius is obviously more enhanced with bend and sensitive fiber being utilized, 5 millimeters compared to the bend radius of a Cat 6A solution of 30 mil. The tensile strength is much greater. So if we have a look at the overall gains you get As you can see, passive optical LAN using single mode fiber, it can run 400% further than Cat6a, is 60% smaller, weighs 90% less, has a 600% better bend radius, double the tensile strength, and costs less. This is why it's gaining traction here in NZ and obviously internationally as well. And more organizations are making the switch to passive optical LAN as their infrastructure of choice. So one of the things to actually be a little bit careful of when you're actually looking at passive optical LAN, can you overpower the receiver of an ONT and damage it? The answer is yes, you can. There are two classes of passive optical LAN PON ports, Class B and Class C, with Class B has a total power budget of 28 dBm, Class C a total power budget of 31 dBm. You need to understand that the receiver sensitivity of an ONT and never connect an ONT directly to a PON port. The safest approach if you are doing bench testing is to always ensure a 1:32 splitter, or a 2:32 splitter if you've got one, is in front of the ONT, or you will need to use attenuators. You can damage the electronics and it will be your cost to replace them. So that's what I obviously warn contractors when they're actually installing this stuff. Don't actually connect it unless you've actually got something in front of it. So understand distance loss is critical, particularly when you're engineering and designing these solutions. And the other thing is there needs to be a minimum of 15.5 dB of loss to stop us from damaging the electronics. If we have a look at different splitter losses, now this is a just a generic rule of thumb. 3 dB from 1:2, and then you have another 50% drop of power when you go from a 1:2 split to a 1:4 split, and then again another half power drop when you go from 1:8, etc. So you can see that that is a rule of thumb. If you actually equate that to real world splitters, I often take the first one, which is 1:2, as a 4 dBm drop, and then do 3 from then on, because it's much closer to the actual real world losses of splitters. But again, this is just a rule of thumb, and you can see there 1:32, they're saying minus 15 dB, which is why I said always make sure you've got a 1:32 splitter in front of any ONT that you are bench testing and connecting, or make sure you put in at least 15.5 dB of pluggable attenuation between the ONT and the OLT's PON port. If we have a look at the splitter performance and loss, so these are actual figures, as I said before. It isn't 3 dBm. We should always use the max loss for when we're doing our calculations of loss in the system. And you can see there with 3.8, it is much closer to 4 dB. And if I then add 3 to each of those, I go 7 to 10. So it becomes a lot closer if you start off and allow 4 dB for that first one in the system. So always use the maximum loss, not the typical loss when you're doing your power budget calculations. You've obviously got a number of other standards which are listed across there, from uniformity, return loss, directivity, PDL, and the different wavelengths that they're tested at as well. I won't go into that in this particular presentation because there's a lot of standards, but I can certainly help with understanding those, or you could, if you wanted to, attend the fundamentals course that I run next year. So looking at passive optical LAN design tips, check the total loss budget. The following standard losses apply. These parameters are also provided for those that work in the education sector. The Ministry of Education has just released their version 5. I've just completed the updates to version 5.1, and the Ministry should be releasing those updates shortly following feedback on the presentation we did to the industry last month. So looking at the losses from a standards perspective, you'll see that mated reference to non-reference connector is 0.75 dBm. We have a non-reference to non-reference connector, also a 0.75 dBm. Splicing, allowing for single mode, 0.3 dBm. And because we're utilizing OS2 within the education sector, we've got 0.4 of a dBm per kilometer. Now, one of the things to understand with passive optical LAN, you need to make sure that when you've completed your backbone design, you run through all those counts, particularly if you're using a plug-and-play system like the CommScope system. You need to ensure that each time you have those mated connectors, you do allow that 0.75, and there are a couple of hiddens within the architecture that I'll make you aware of as we go through this presentation as well. So when bench testing, obviously I've already gone through, recommend that splitter, can't reiterate that enough, of 1:32 to drop that 15.5 dB. And the maximum distance limitation by attenuation, fiber loss splitters and connections contribute. Most loss budgets are between 15.5 and 28 dB. Smaller splits and shorter cables require attenuators. So if, for instance, we were only doing a 1:2 with that 4 dB of loss, we would definitely require attenuator to make sure we got that 15.5. So warning, too little loss will damage components. So if we have a look at this quick example that I've got here, you can see splitter loss is based on the maximum loss. So for a 2:32 from the previous slide that we had before with the CommScope splitters, it's 17.4 dB of loss for the 2:32. We have 500 meters of fiber optic cable, it's actually 5 kilometers, should I say, of OS2 fiber, which equates to 2 dB of loss. We have connectors and splice losses of 3.45. Fiber loss, obviously, connectors is based on 4 times splices and 3 times mated connectors at 0.75, providing us a total loss of 22.85 dBm. So that is well within the 28 dBm budget, and obviously provides us with headroom using a Class B PON port. It also means that we don't have to provide additional attenuation because we are above the 15.5 dB of minimum loss as well. So looking at a couple of the areas which are gotchas, particularly with plug-and-play solutions, when you're calculating them, this particular image that we have here is from CommScope, and as you can see, we have LC to LC mated connectors. These particular connectors on the left-hand side here are coming from the 2:32 splitter. From the 2:32 splitter, we are then using those to actually convert to our MPO connectors, our multiple push-on connectors, and they are going out into the field to a rapid deployment terminal. So at the point that we are splicing them at this point here, and then they are coming out of the splice into the multiple push-on connector, and then mating with a multiple push-on connector. So we have to remember that we've got 0.75 of a dB loss here because it's mated connectors. We have 0.3 dB loss here because we have fusion spliced onto the ribbon fiber from the 900 micron that's going out. So the 900 micron off of the LC connectors here, which is then going into here, we're coming out with the ribbon cable, and the ribbon cable going into the MPO. We then have mated pair here again, MPO to MPO, so again 0.75 dB. So often this fusion splice is missed, or they miss the MPO to MPO mated pair, or you miss the coupling between there. This is a full plug and play solution, so we have to make sure that we do pick up those losses. Looking at the rapid deployment terminal, again, this is a plug and play solution from CommScope that I'm just taking you through as an example. So out in the rapid deployment terminal, we have the MPO connector coming in. That then is spliced onto the 900 micron back end of an MPO connector in the back of the rapid deployment terminal. That then comes out and feeds the SC APC connectors here within the RDT, and then obviously from those SC connectors we go out to the ONT. And the reason we are presenting SC connectors here is because at this point here, typically we either have ONTs directly connected to the RDT, or these go away to a fiber faceplate. In both of those situations, the ONT uses an SC APC connector, and hence we want to keep the two the same. So we're going angled SC to angled SC on the ONT directly, or angled SC to an angled SC coupler on a fiber faceplate. So again, if we are taking this across to a fiber faceplate, when it gets down to the fiber faceplate, you have to allow, again, another 0.75 dB of loss at the fiber faceplate, because again, you'll have a mated pair when you put the fly lead or the fiber single simplex patch cord from the fiber faceplate to the ONT. Looking at a quick look at a couple of designs. This here is calculating budget loss and will it work. This particular one here, this is a backbone diagram from your core switch to your OLT, I should say, from the OLT out to each of your 2:32 splitters. In this particular example here, you can see we've got some centralized splitters on the left-hand side of the diagram here. And then we've also got some distributed splitters out in different cabinets out in the field as well. So gymnasium, you see this is an education facility. We've got a splitter at the gymnasium, a couple of splitters in the multi-purpose. And again, design, it's important to understand from a design perspective what the distances are and whether a fiber-rich backbone is important, or whether, and the cost of an actual splitter versus collapsing it all back into a central location and running multiple fibers to provide that expansion. But again, as a designer, you need to understand that budget and flexibility constraints, and also providing the customer the best future-proofing example based on whether you want to come fiber-rich in the core, or in the backbone, I should say, or whether you want to distribute it and provide enough capacity within the backbone to be able to increase those splitters if you need to later on. So will this particular system here work? The answer is yes. There's 17.5 dB of loss in the splitter, and 0.75 dB per connection in the MPO, LC and SC, including the 0.3 dB that we saw before in the splice end to end. And if we assume for the gym, multi-purpose room and the learning hub, then each backbone leg would be 500 meters of fiber. So again, from the example that we showed previously, this would be well within the overall losses. Would this particular example here that I've shown on the screen work? The answer is no. The reason being is the previous example, if I just go back to that previous example, these two examples are exactly the same, except this example that's on screen now is the one which was the final design. Unfortunately, the draftees that were drawing up the design left some artifacts on. Those artifacts, originally, we were looking at a centralized splitter design. As you can see, these splitters down here. Then I've got a 2:32 splitter running to a 2:32 splitter. Now I've got 17.4 dB of loss there. I've got 17.4 dB of loss there. Total of 34.8 dB of loss. It's not going to work. Not even with a class C can I get that to work. So straight away, this diagram is incorrect, and obviously, unfortunately, those were left on the diagram. They should have been deleted. But it is important to check your work and make sure that there are no things like that when you produce your final designs. If we have a look at this, this last example on the screen here, and whether this will work or not, it's a little bit more technical, but the answer is also no, it won't. Up the top here, which you'll find a little bit difficult to see, I have a total number of ONTs on both sides. 2:32 splitter, obviously I can have a maximum of 32 ONTs running off of one 2:32 splitter, because I have 32 ports available to plug them into. The total number of ONTs, if I add them up in these particular sections here, comes to 37. So while distance and loss isn't an issue, I just have too much connectivity to cope with the centralized splitting. So therefore, this particular example here won't work because it's oversubscribed from a splitter perspective. So it's not a loss issue, it's an oversubscription of splitters. So an additional splitter needs to be added, or the load needs to be rebalanced from a central patching perspective on those centralized splitters. Now, labeling, I can't emphasize enough how critical it is to actually come up with a really good labeling scheme up front. So the consultant should provide the labeling scheme. The above scheme that you can see here is from Talk IP specification. It does get modified depending on the installation requirements, and additional options have been added recently for a council installation that had an ONT connected to a fiber faceplate that in turn fed a point-to-point copper link for a TV on the other side of the wall from a meeting room. and this is not obviously catered for within this particular labelling scheme. This labelling scheme follows Ministry of Education New Zealand standards in that the labelling in the backbone section in particular, it has the same labelling scheme, and we kept it that way for all of the ministry installations, but we've adapted that labelling scheme for any commercial installations we're doing as well. So labelling scheme, really important also to sort out the labelling first, also the different service templates that the ONTs require, because it's not just triangles on a page anymore. With a passive optical LAN solution, the whole solution has to be engineered, not just the physical infrastructure, but you have to understand how the service templates are going to be deployed, what ports are going to connect to what. You have to look at the ONTs, what PoE power requirements there are. You know, there are a number of issues that we've run into where one particular provider, their ONT could not power more than one wireless access point. Well, it could power them, you just couldn't roam between ports on the ONT. So those are the sort of gotchas that you actually learn when you start to engineer these. So you actually have to understand not just the physical infrastructure, but the actual electronics infrastructure that you're engineering as well. It's important that the contractor that's actually putting the system together provides you, as part of their installation, the shop drawings with the labelling schema as well for verification. It is obviously slightly different to a traditional copper cabling installation, and it's important, as you can see with that previous labelling schema that we had before, that point of origin all the way through, and it takes a while to come up with a labelling schema that works. This took quite a number of hours to actually go through and produce, and a number of iterations to get it right. So thank you for attending the presentation. Hopefully that's given you a few insights into Passive Optical LAN and some of the benefits of it, and some of the technical gotchas that are there, particularly with loss, and additionally when you're designing it, how important labelling is, and that it isn't just, you know, triangles on a page. It requires to be engineered. So thank you for attending.
Excellent, thank you very much, Phil. Just whilst we wait for other questions to drop in, if there are any others, I've just got one there from Paul Collins, and that is there a point where PON is not economical given the drop count being low in some installation types?
Yes. So, well, actually it all depends. And I would say traditionally with the, say, OLT providers from, say, Nokia, Calix, Tel Labs, Zone, then the break point is around 200 to 250 drops. So if you exceed that, then it definitely comes into its own, and particularly over the total cost of ownership, it definitely is viable. If you are designing it for a small organization, there are standalone OLTs which are very cost effective from those manufacturers, and also, dare I say it, there's a new entry from Ubiquiti. They do a little 4-port ONT, which is extremely cost effective. Sorry, a 4-port OLT, but their edge ONTs are only single port. So again, it's horses for courses. It depends on the product set that you're matching with it, but typically that break point is around that 200 to 250.
Okay, thank you. And on the ONT side of things, just a vague or sorry, brief overview of the different configuration types that you've got. So you've mentioned 4-port for argument's sake. What other flavors do you get?
So it depends on the manufacturer. I would say there are certain manufacturers, I'll just pluck one out of the sky, let's say Zone, or Desan Zone as they're known. They have so many different versions of ONTs available. You can probably just about find a form factor that would fit. The Waikato Regional Council, the one that I mentioned before with Nokia, we're using both 4-port and 12-port. So they come with 8 fixed ports and 4 SFP modules that we can put off the side of that. There are other vendors that actually have up to 24-port ONTs. So you can essentially, if you wanted to replace a traditional switching network, if you had single mode fiber in the backbone with ONTs with 24 ports on them. The other common footprint is an 8-port, as I say, but from an ONT perspective. You can get them with RF built in. We don't utilize them here in NZ because there's only one ONT manufacturer out of Spain, I believe, that can do the range of RF signals we need to support Sky terrestrial satellite signals. So generally, we are not integrating the RF deployment at the 1550 nanometer into the ONT. But we do have POTS ports, Plano telephone service ports, available on the ONTs, as well as standard Ethernet ports and PoE ports. The other gotcha with ONTs and form factors is the power output. So manufacturers will say that the ONT data sheet, for instance, gives you 120 watts of power across the 4 ports, which you would say, okay, that's 30 watts a port. However, the standard power supply that comes with the ONT typically only delivers 60 watts. So that's a maximum of 15 watts, and that doesn't include whether the actual ONT electronics themselves are actually using any of it. So if we take Nokia as an example, they have an 80 watt power supply, but that gives you then the 60 watts, so you can do 15 watts per port, but they are unable to deliver with the standard power supply out of all ports. The way to get around that, of course, is if you centrally DC power them, and then you can use the full wattage of the actual ONT. So hopefully that gives you a quick overview of different form factors and answers the question.
Okay, thank you very much. And then just last couple of questions, and just a bit way of the time. One is one of the use cases you spoke of was aged care. Do you have a healthcare use case or an example that you could share? And off the back of that, type B, C, and D protection schemes for PON, as in, I believe what you're talking about there, David, is the redundancy patterns. He knows that a certain vendor that's of a Chinese source, should we say, does it, but he can't use them on his particular facility.
The answer is yes. So we always engineer our, so if we, which question do we start with? So if I start with the redundancy question first, and then if you could just repeat the question, Craig, for the other one, just so I can come back to it. So from a redundancy perspective, the FSAN type B redundancy, just about every system that we engineer, we design that into the actual cabling infrastructure up front. So the splitter of choice, or the most common splitter utilized, is a 2:32. There's obviously a lot of different, there's some over engineering that we're seeing with vendors selling to their end user clients much lower split ratios because they want to guarantee the bandwidth. But if you use the dynamic capability of a passive optical LAN network, then you'll find that there's very little need for that. When we have a look at ECAN, for instance, they found that on their PON solution with the 2.5 gig down and the 1.25 gig up, that most of their end users used a maximum of 8 megabits per second, well underneath the range of the system. And never during the whole time it's been installed since 2012 has any single PON port got anywhere near a 70% threshold of the total bandwidth available on a PON board. So, and that is utilizing 2:32 splits. So if you imagine that 2:32, each of those 32 fibers has a 4-port ONT on it. We engineer the 2:32 up the front. That means we can actually have dual line cards, dual CPUs, and that essentially gives us 5 9 dual power supplies, and in some case, not just dual power supplies because it's the most vulnerable part. We go for N+1 over the top of that. So we have the ability to lose a CPU, a line card, PON port, and sub 50 millisecond changeover to using FSAN type B redundancy is the most common. Type C, not so common. I haven't engineered any solutions myself. And then, actually, I think I remember the other question now, Craig. From a healthcare perspective, other than aged care facilities, we have looked at utilizing it in healthcare. And the example that I gave before for the power calcs was the medical facility in the US. Here in NZ, unfortunately, most of our healthcare facilities have Cisco in them. And while Cisco does have a passive optical LAN solution, they're not willing to go away from their Cisco management platform, and therefore at this stage there are no health facilities yet that have passive optical LAN in them, other than aged care.
Okay, very good, thank you. Yeah, that's often the case, isn't it? Yeah, I think the platform they bought some years ago was a Brazilian manufacturer, I think it was, or some South American company. I can't remember what it was, the famous Crisco acquisition, in that they bought it and then did very little with it. One of the other questions here is maximum number of splits recommended in a PON.
Maximum number of splits, again, I wouldn't go above the 32. There are occasions, because of course you've got losses involved, I would limit yourself to that 32. Now, where it becomes an advantage, let's say, I'll take an example of a library, and you've got a service desk within the library, you've got a channel conduit running through the slab out to the service desk, which is an island. Getting cables, much easier obviously getting cables back through to that location when you're using passive optical LAN, because the fiber is much thinner. But let's say, for argument's sake, it wasn't possible because when the cables were running there, the guy that was actually pouring the concrete did a sloppy job of it and reduced the amount of capacity, and we were only able to get that one cable through. Now, that one fiber cable, within the fiber faceplate, we could very easily put a 2:1 splitter, which would add that 4 dB. And if we go back to the example of the maximum loss we saw in the example I gave you, a 22.85 dB, if I add that 4 dB of loss, still takes us to 26 dB, and we still have headroom under that 28 dB in a class B, and we can obviously put a class C in if we needed to go higher. But essentially, we could then drop a 2:1 splitter at the faceplate without having to run through any firewalls, without having to run any extra cables, and we can then split that fiber into an additional 4-port ONT, or equally, we can actually just take the 4-port ONT off and put an 8-port ONT on and expand the number of local ports as well. So there's a lot more flexibility at the head end, or actually at the termination point. If you compare that to, say, a traditional UTP network, if I wanted to take a data outlet and turn it into 2 data outlets, which is possible, not recommended obviously, but you often see them inside cabinets where they've got splitters utilized so that they can drop the Ethernet connection into 2, because they've got 2 computers that are required. But of course, in doing that, you drop it from gigabit down to 100 meg because you've only got the 2 pairs available. And you can only get a maximum of 2 Ethernet ports versus a single fiber optic cable, where the only limitation is the number of ports on the ONT that you're deploying. And if you wanted to keep the same form factor as mentioned, very easily put a 2:1 split in, and then drop 4 port ONTs on both of them, providing you double the expansion and keeping the spares the same. So recommendation is go to a maximum of 2:32. We have seen some engineered with 2:16, but 2:16 increases the electronic head-end costs, particularly with FCAN type B redundancy, where you're having to do dual line cards. Currently, there are no line cards that I'm aware of from any manufacturer that can actually hold XGS PON or 10 gig PON and 2.4 in the same line card. You can combine on the same infrastructure though, 2.5 and 10 gig. So on the same single fiber, you can carry both simultaneously, and you just change out the electronics on the other end. Because they're using different wavelengths, they don't interfere with each other. You haven't had to change out any of the actual infrastructure at all. You're just using a wavelength combiner at the head end. So hopefully that helps.
Excellent, thank you very much, Phil. I think I remember speaking to someone about GPON a few years back in Australia, and he used a phrase which I think is relevant, and it's pioneers get the arrows and settlers get the land. And I think that relates to New Zealand and Australia specifically here, and I can say that because I'm English, in that you guys seem to be pioneering the use of this technology more substantially, I think, than typically what's being done across Australia. I can't tell you why that is outside of market forces and concerns and things like this, but it's good to see that you've got a good portfolio of projects that people can take confidence in, I think, on this side of the pond. And also, of course, you've got a lot of New Zealand people on the call as well, so you can take some solace in that, I think. I think that's it for the questions, unless you've got any other points to add, Phil. Just looking through the questions here. No, I think we've covered them all off. You've got a number of thanks on there for a great presentation. If anyone's got any further questions after today, feel free to reach out to myself. There's Paul. Paul Status, just come back and join us there, and we'll pass those questions on with your regards. So just over to you two, just to close out, and then we'll finish the session.
Suppose just a quick one, if I may. So as I mentioned at the beginning of the presentation, this is just a small sample of the Talk IP Passive Optical LAN training, online training course that I deliver through Microsoft Teams. So if there is anyone that's interested in attending the bigger training course next year to actually learn more about Passive Optical LAN and go through all of more technical questions, remote powering, that kind of stuff, feel free to actually email info@talkip.co.nz, and we'll be happy to provide you with information on the course that I'll run next year.
Thanks very much for that, Phil. In fact, I might just close out just a few concluding comments. First of all, thank you to Phil for that very succinct presentation. I know it's a very complex subject. You worked hard to just précis that down to a 1-hour presentation, and we thank you for that. I'm glad you mentioned this is really part of a full-day training program that you run. This is particularly to educate the industry, and I should also reiterate the fact that Talk IP is it's a technology and vendor independent advocate for end users. The team at Talk IP are all technologists, and their focus is to assess and identify the requirements of their clients and then provide the most appropriate technological solutions for them. And this is where perhaps Talk IP have gotten heavily involved with the element of passive optical LANs, for the fact that they've done the research and they've explored. They're not advocates for any particular vendor or any particular technology. This is just simply the result of their research and the benefits that are conveyed onto their clients. So I'm pleased to have had this presentation presented. It is only a small summary really of the overall subject, and as Phil mentioned, there's a lot more to benefit from with a full education program. Phil, I think you said it's a Teams run program, so someone in Australia or someone in New Zealand could attend and get the benefit of a full day of education on passive optical LANs. So that's a great thing. Just also wanted to say thank you to R&M and to Craig Buckingham for facilitating this platform for us. We do appreciate this. This gives us a very stable platform that we can host our webinars from. And we do alternate each month between R&M's GoToWebinar and Fluke's WebEx platforms. So we'll be alternating between those. We haven't run them every fortnight as originally planned. We've had just situations where people haven't been able to present. So we do apologise if you had looked forward to a particular presentation. We will be working on the program moving into early December. We won't be running anything going through the late December, early January program, and we'll look at reintroducing again in February. As we mentioned earlier, we are looking at a number of physical web seminars once again coming back to normality. So if you are in those locations where we're going to run them, you're most welcome to attend, and I'm sure you'll probably benefit tremendously from just the physical interaction with humans rather than over virtual platforms, which we've done for quite some time. Just another quick comment. I just wanted to pick up on Phil's comments, that things that I particularly picked up, the gotchas that you talked about, Phil. One was the element of oversubscribing versus loss. So the dangers that we might have, that our loss budget we think isn't right, but it could be potentially oversubscribing. So being aware of that, and the importance of labeling to make sure that gets done correctly. It's not just a case of getting it done for day one, but the client has to live with the infrastructure for quite some time and deal with the adds, moves and changes, the office dynamics, so to speak. So importance of labelling. So I do thank you for those very practical comments there. One last thing I will finish off with, just a reminder for BICSI members, our annual general meeting is being held next week. It is on a Zoom platform. We have sent out invitations. There will be a reminder invitation going out later this week as well. But if you are able to attend, you're certainly most welcome to do so. It's scheduled for, I'm trying to remember, I think it's next Wednesday, 11 a.m. Australian Eastern Daylight Saving Time. But we will send you out a reminder on that. It will be held on Zoom, so you are able to attend, which will be just for a short hour program. So with that, I'll conclude and thank everyone for attending. Thank the participants, thanks for the speakers, and thanks for the hosts. And we look forward to our next webinar. Thank you.
Thanks very much.
Thanks all.